Hi there, this is Snula. In this video we're going to look at RAID 5. First of all, how does RAID 5 work? You need at least 3 hard drives to set up a RAID 5 array. And what happens inside the array is that the RAID controller will stripe the drives together, like in RAID 0, but it will also add something called parity. Parity is the end result of a comparison between sets of data written to different drives. I'm going to show you in my example. It's going to be hopefully going to be understandable, but we'll see about that. The advantages of RAID 5 is that you have increased read speed and that you have also redundancy. And the disadvantages of RAID 5 is capacity yield. In my example here, there are 3 hard drives and all 3 of them are 1 terabyte. And with RAID 0 you would have a 3 terabyte virtual hard drive. With RAID 5 you will lose the capacity of 1 drive. So in this case we have a RAID controller, and what it presents to the operating system is a drive of 2 terabytes. When we take a closer look at what happens when the operating system is trying to write some bits of data to the disk drives, what the RAID controller will do is take the first half of the 8 bits and write it to hard drive number 1. It will take the second half of the 8 bits and write it to hard drive number 2. Keep in mind this is simplified because it writes in much bigger chunks of data, but this is just to simplify how it works. As we see now, there's no difference from what happened in RAID 0. We took half of the data and wrote it to 2 hard drives, and we still have a 3rd hard drive. And why do we need it? It's because of the parity. And when the RAID controller creates the parity bits, it uses a table called exclusive OR, and it will compare bits and will output a parity bit as a result of the bits it compares. And we're gonna try to see how it works. In this case you see that hard drive number 1 has half of the data we got from the operating system, and the first bit is a 1. And hard drive number 2 has the second half of the data, and the first bit is 1. And according to the table marked in yellow here, 1 plus 1 equals 0. So on hard drive number 3 the first parity bit will be a 0. When we go to the second bit, we see that hard drive number 1, the second bit is 0, and hard drive number 2, the second bit is 0. So according to the table, the second parity bit is then a 0. We go to the third bit, hard drive number 1, the third bit is 1, hard drive number 2, the third bit is 1, and according to the table, 1 plus 1 is a parity bit of 0. So that's what gets written to hard drive number 3. And we have the fourth bit, 0 and 0, and according to the table that's a 0. Now we have written, the RAID controller has calculated the parity bits and written them to hard drive number 3. This of course takes a little bit of time, so you will not have the right performance that RAID 0 has. We have a second set of data here. Let's go through that. First half gets written to disk number 1, second half gets written to disk number 3. And why is it written to disk number 3? That is because RAID 5 will spread the parity bits evenly between the drives. And why it does that is because when you have a hard drive failure, that will increase your performance. and we'll take a look at that a little bit later. And once again, the rate controller will calculate the parity bits. First half of the data is on hard drive number 1. That's the first bit is 0, and on hard drive number 3 there's the second half of the data we got from the operating system, and that the first bit there is 1, and according to the table 0 plus 1 equals a parity bit of 1. Second bit 1 on each side, and that will create a parity bit of 0. And the third bit also 1 on each side, and that will create a parity bit of 0. And the last bit of the data, 0 on hard drive number 1 and 1 on hard drive number 3. And according to the table, 0 plus 1 equals 1. Now we generated the parity bits for the second set of data. And this will just keep going. The rate controller will do this all the time. It will move the data from the operating system, the memory, to the disk drives. It will calculate the parity bits, and it will distribute it evenly between the drives. What happens if a drive fails? Of course, all the data on the drive that fails will be lost. Would that mean that the operating system will see that the drive is gone? Will the data be lost? No, it won't. As we'll see here, the rate controller, if the operating system tries to access the first piece of data here, it will the rate controller will take the first half, give it to the operating system, and take the second half and give it to the operating system, so the data is intact. While on the second line here, the first half of the data is intact, but the second half is gone because the hard drive number 3 died. But we still have the parity bits. Do you see the operating system here now gets the first 4 bits because they are intact, and the rate controller will pull up its exclusive OR table, and it will compare the bits of the original data and the parity bits. As you see here, the first bit on hard drive number 1 is a 0, and the first parity bit on hard drive number 2 is a 1. And in the table you can see that that leaves us only with one option, that the original data on hard drive number 3 must have been 1. And second bit 1 on hard drive number 1, and the parity bit is 0. That leaves us with only one option. The original data on hard drive number 3 must have been a 1. And third bit 1, parity bit 0. That leaves us with one option. The original data must have been 1. And the fourth bit 0, and the parity bit is 1. That leaves us with one option, and that would mean that the original data on hard drive number 3 was a 1. And when you read each set of data, the rate controller will calculate what the original data on the defective drive, what the data was. So you will be able to access and read all the files even if a drive fails. And when you replace the drive, the rate controller will either automatically, depending on its price actually, or you can start it manually if you have a crappy one. It will rebuild the third drive. It will take the data from the hard drives that are still alive and write it to the hard drive number, the new hard drive. As you can see here, it won't. Oh, my bad. It won't write the data. It will create parity bits in this first case here. And when it compares with the table here, you see that 1 plus 1, we have the first bit on hard drive number 1 and the second bit on hard drive number 2. 1 and 1, according to the table, will give 0, and a 0 and a 0 will give 0, and a 1 and a 1 will give 0, and a 0 and a 0 will give a 0. It will rebuild the original data based on the first half and the parity bits, and as you can see, it will rebuild the entire content of hard drive 3 as if it was never gone. And there you go, you have rebuilt your RAID array.